So before you look at those words and go, oh my gosh, graphing linear inequalities, oh, it's so scary and bad, slow down and realize it's not that bad. You know how to graph linear equations, as in like graphing a line, correct? You can make these all you want. Inequality, that's where we take out that y equals and we write y does not equal, meaning we write greater than, or we write less than, or we write greater than or equal to, and less than or equal to. Oh, that's not so bad. Okay, the only thing is with graphing them, there's a slight change, and it's not that bad. One important thing to think about is that, do you remember when we did things like if I said x is greater than 2, okay, you had to think about, is that an open or closed circle? Meaning I'd come to 2, I'd put a circle around it, and I had to think about, is it open or closed? Then if I put or equal to, you had to again think about it. And remember that what we decided that was that if you said just greater than, or if you said just less than, that was an open circle. If we had the or equal to part, it was closed. Okay, same idea, except that with inequalities, and we're talking about linear inequalities, we have solid or dotted lines. Think about the solid as being filled in or closed. Think about this, right? Like with our closed circles, which were our less than or equal to and our greater than or equal to, we filled them in. We took up all the space possible. Same way, we will actually make solid lines. But if we talk about our less than or just greater than, we kept open circles, and in the same idea, same fashion, we will do just dotted lines. So let's say I have the linear inequality, y is less than or equal to x plus 2. Alright, to graph it, same as when I was graphing all the other ones. I would say this is my starting point, which is my y-intercept. So I'd say that's at the point where x is 0, y is 2. So that's right there. Now I have just positive x. That's like 1 over 1x, as in up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and then if we were to go backwards, down 1, left 1, so on and so forth. Okay, as I just finished saying, whenever we have this less than or equal to, or if we had greater than or equal to, what we would do is we would make that open or closed. Closed was what you did say, right? I know. Since you said it was closed, we will make it like a solid, which was closed, as in like all the spaces are filled. We will make a solid line. Okay, now what you need to do is you need to figure out shading. Uh-oh, now there's a little more. And before you say, oh, no, I thought that was all we had to do, it was so easy, no. Calm down, it's not that bad. All right, so what you need to do is pick a set of points. So meaning like any point you want that's on this graph. So like that's not on the line. So I could pick the point right here, I could pick a point right here, I could pick a point right here, doesn't matter. Pick any point you want, and then you will plug in that x and the y value in your equation for x and y. The simplest usually is to put in 0, as in like the origin. So if I put in 0 and 0, as long as it's not on that line, or as long as it's not too close to the line, it's going to make it pretty obvious. What I mean by that is this is at the point 0, 0. Plug that in. Our y value is 0, less than or equal to just x was the original problem, so we'll say 0, which was our x, plus 2. Now I have 0 is less than or equal to, what is 0 plus 2? 2. Is that a true statement? Is 0 less than or equal to 2? Yes. So since it is, we shade in this region right here. Because what we mean is that any value you pick will work for that. And I'll show you. Let's do one more value. Let's pick this point right here, just in case you don't believe me. That's at the point where x is 6 and y is 1. So we have 6 comma 1. Plug in those values. Our y value means 1 is less than or equal to, and then our x is 6 plus 2. Okay, 1 is less than or equal to, what is 6 plus 2? I think it's 8. That's also true, so that means we shade it in. I'll show you what happens. And you say, well, what happens if I pick a point that wasn't? Like, what if I pick the one that was over here? And this isn't right. Okay, so what you do is you say, what is that point? That's at the point -4 and 3. Let's plug it in. The y value would be 3 less than or equal to, and then we plug in our x value, which is -4, And then we say plus 2. So we say 3 is less than or equal to, what's negative 4 plus 2? If you told me negative 6, I'm getting sad because by this point we should be past that. We should be able to say that that's negative 2. So 3 is less than negative 2. Is that true? No, that is not true. So we know that anything on this side is not where we're going to shade. So we know we just shade the opposite. And again, we would just shade over here. So before you say, oh, but Mr. Sauter, that was so confusing. I'm coming to tutorial. Try this one again, and we'll see what happens. So let's say we had the equation y is less than negative 2x, and we'll say plus 1. Okay. Now, to graph that, remember my starting point, which is my y-intercept, is 1. That's the point where x is 0 and y is 1. So I'm going to put that right there. Now I have negative 2x. That's like negative 2 over 1, right? So I know that from my starting point, my y-intercept, I go down 2 spaces into the right 1. Again, down 2 spaces into the right 1, down 2 spaces to the right 1. Since I'm kind of running out of space, I'll go up and to the left 1, up and to the left 1. Okay, what did I say? Whenever we have less than or greater than, what we would say is that open or closed circle. Remember that? It was an open circle, and then as far as lines go, that means it's a dotted line. So we'd say dash, 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 dash. A bunch of times, make a dashed or dotted line like that. We don't fill it in. Again, it's like the circles. We don't fill them in. Okay, now we've got that line, and it's been graphed, but we still have one more step. And again, like I said, before you come to tutorials, like, oh my gosh, I don't get it. Watch. Pick a point. You can pick any point you want, and you can try this yourself. So what I want you to do is pick your own point right now. So like I said, try to pick a point that's not too close to the line. Meaning, let's pick a point right here. Let's pick this point, which is negative 3 and negative 3. Now what I want you to do is to do everything I'm doing, but do it with the numbers you did also. So plug in that value. So y for me is negative 3 or whatever you picked, less than negative 2, and then plug in our x value, which for me is negative 3. Then we say plus 1. Do the same thing for yourselves. So I'll hold a second. Okay, did you plug in your x and y coordinates? Now I have negative 3 is less than, what's negative 2 times negative 3? It's positive 6 plus 1. Negative 3 is less than, what's 6 plus 1? 7. Is that a true statement? Since that is a true statement for me, I'm going to go ahead and shade in this side that is a true statement. Okay, did you get one that was a true statement? If so, it was probably somewhere in this area, wasn't it? Did you get one where it was true? If you got one that wasn't true, that means you picked something over here. That's not wrong. That's okay to do. You just know that if it's not true, you shade the opposite side of where you picked. And I'll pick one over here just to show us what I'm saying. So let's pick a point right here. And again, I want you to do the same thing. I want you to pick one on the opposite side, the left or the right of whatever you picked. So let's pick this point. Let's pick right here. Again, I want you to do this along with me. You pick your own numbers that are on the opposite side now of that line. So this is at the point where 4 for x and 2 for y. Okay, plug that into our equation. We'll say that 2 is less than negative 2 times 4 plus 1. Okay, 2 is less than, what's negative 2 times 4? Negative 8 plus 1. Okay, 2 is less than negative, is it negative 9 or negative 7? Let's get past this. It's negative 7. Okay, negative 7 is not actually greater than 2. So we know that this is wrong. Okay, knowing that's wrong means that we need to go over here and shade this side. Again, whatever numbers you picked, you should be able to do the same thing.